Welcome to Maths and Science by IITian channel. In today's lecture, I will be taking up a harmonic sum to get the value of smallest prime factor of A plus smallest prime factor of B. SPF is the smallest prime factor, and the sum of the harmonic series is equal to A by B, A divided by B. That means, can we say this particular value SPF of A plus SPF of B as a Diophantine equation? This particular equation, whatever is given, this function is function of AB. Sum of the harmonic series is the function of AB, that is equal to A by B, where A and B are positive integers, and we have to find out the sum of smallest prime factor. SPF is smallest prime factor, SPF, smallest prime factor of A. This is smallest prime factor of A, what we have to find out. And here what we have to find out is smallest prime factor of B, and by summing them, what will be the value? Single equation, two unknowns, and both A and B are positive integers. Then can we treat it as a Diophantine equation? You please conclude on yourself. Now, what we have to find out in the equation is, in the question is, smallest prime factor of A plus smallest prime factor of B is equal to how much, if A and B are positive integers. The left hand side is sum of the harmonic series, that is 1 plus 1 by 2 plus 1 by 3 plus up to 1 by 16. That is equal to A by B, where A and B are positive integers. And we have to find out smallest prime factor of A plus smallest prime factor of B is equal to how much. Here in this, we will be using the WOLSTENHOME'S theorem. We use a shortcut, WOLSTENHOME'S theorem. How to use it? We learn the concepts of it in this particular problem. Let us try to solve it. Here the question is to find smallest prime factor of A plus smallest prime factor of B is equal to how much when sum of harmonic series 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by 16 is equal to A by B. To solve this, we will use the WOLSTENHOME'S theorem. WOLSTENHOME'S theorem. As per this, if some summation of harmonic series is taken like this: 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by p minus 1, that is equal to a by b, then it implies, please remember this, a is equivalent to 0 mod p square. This is very, very important, where a is the numerator, p is equal to number of elements in the harmonic series. Now, we will apply this theorem and let us see. Here what is the series given? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by 16 is equal to a by b. Here, from the above theorem, what is p minus 1? P minus 1 is equal to 16. This value is p minus 1. That implies p is equal to 17. As per WOLSTENHOLME'S theorem, a is equal to a equivalent to 0 mod p square. That equivalent to, that implies a equivalent 0 mod 17 square. Which implies smallest prime factor of a is equal to p, that is equal to 17. This is very, very important. Please try to understand this. That means the smallest prime factor of a is equal to 17. Please, as a homework, please try to verify this theorem by using p is equal to 5. If p is equal to 5, can we apply this theorem? Try to find out. This is homework. Now, we have to find out the smallest prime factor of b now. What is b? B is nothing but the LCM of all the values of the denominators. Now, what is b? 1 by 1 plus 1 by 2 plus 1 by 3 plus up to 1 by 16 is equal to, when you do it manually, it will be 1 into 2 into 3 into 4 up to 16. Then this value will be 2 into 3 into 4 into 5 up to 16 plus 1 into 3 into 4 into up to 16 plus 1 into 2 into 4 into up to 16 plus so. Already we have found that this particular value is numerator a, and it is defined already. This particular value is denominator b. For a, we have already found smallest prime factor of a is equal to 17 as per WOLSTENHOLME'S theorem. Then b is a even number because it is multiplied by even values, even number. For an even number, what is the smallest prime factor of an even number? Smallest prime factor of an even number is 2. That is the smallest factor. Very important. For odd we don't know. We have found out from Wolstenholme's theorem. For even it is a direct value, that is 2. Then what is the given question? 1 plus 1 by 2 plus 1 by 3 plus up to 1 by 16. It can be written as some capital X into smallest prime factor of A divided by some capital Y into smallest prime factor of B. This is equal to some X into smallest prime factor of A is 17 and some Y into smallest prime factor of B is 2. That implies smallest prime factor of A plus smallest prime factor of B is equal to 17 plus 2, that is equal to 19. Answer. Similar way, if it is gone up to 1 divided by 2025, there also we can easily find out. For example, as a homework, try to do it. Find sum of smallest prime factor of A plus smallest prime factor of B if 1 plus 1 by 2 plus 1 by 3 up to 1 by 2025 is equal to A by B. I will give the hint here. What is P minus 1? This is P minus 1, that is 2025. What is P? P is equal to 2026. A is equivalent to 0 mod 2026 whole square. From this, you can find out the smallest prime factor of A. Try to do it, if you can do. Or, but here the value is P is not a prime. That is the problem. Not prime. Hence, there will be a question mark. For example, if it is because that P should be a prime. Let us try. Up to 1 plus 1 by 2 plus 1 by 3 up to 1 by 2026 is equal to A by B. Here 2026 is P minus 1. Then what will be the value of P? P is equal to 2027. Just check up if it is prime. Just check up. How to check up whether a number is prime or not? You have to go through the process. Square root of 2027 is around 43. 43 primes you have to check. Otherwise, you can go for a smaller, better method is A square minus B square is equal to A plus B into A minus B. a square minus b square is equal to a plus b into a minus b. From applying this also, we can find out the value of a particular number is prime or not. If it is prime, if a square minus b square is equal to prime, then what happens? A square minus b square is equal to some 1 into a plus b. Sorry, this is minus. Are you able to follow this? That implies a minus b is equal to 1. Because prime will not have a factor other than number itself or 1. A minus b is equal to 1. You please cross check whether with a minus b nearby values a square minus b square you are getting whatever number is given, is it fitting in this or not? For example, here 2027, is it prime? That's what is required to be found out. Now, if it is a prime, it will be written as 2027 is equal to a square minus b square, that is equal to 1 into a plus b. That implies a plus b is equal to 2027. And a minus b is equal to 1. That means 2a is equal to 2028. A is equal to 1014. B is equal to 1013 from above. That 1014 minus 1013 into 1014 plus 1013, that is equal to 2027. By reverse applying also, we can use to find out whether a particular given number is prime or not. At least it will give an idea. It can be treated as a prime. Then what is a square minus b square? That is equal to 1014 square minus 1013 square. Let us see what will be its value. That is equal to 2027. Either way, we are able to get it. You apply and you can safely apply it using square root of 2027, that is up to 43 primes, up to 43. What are they up to 43? 2, 3, 5, 7, 13, 17, 19, 23, 29, 31, 37, 41, 43. and you can combine this, our previous theorem, a square minus b square is equal to a plus b into a minus b. That also you can combine, and you can arrive at a particular solution or a particular conclusion that a given number is a prime. If the given number is a prime, let us say 2027, that is a prime. Let us say we have established. Now, what is Wolsten theorem? Wolsten theorem says, WOLSTENHOLME'S theorem, 1 by 1 plus 1 by 2 plus up to 1 by 2026 is equal to a by b, implies p is equal to 2026 plus 1, that is 2027 is a prime. Hence it implies that a is equivalent to 0 mod p square. That means a is divided by p square, divisible by p square. That implies p is equal to 2027 is the SPF of A. Now, you just see how easily we are able to find out for any number. This is the SPF of numerator, because numerator is a combination of many multiplications. It's a very big number, numerator. Denominator is the product of all the numbers in the denominator of each number. That means the smallest prime factor of this particular problem is whatever is given to us is 17. SPF of numerator is 17 and SPF of denominator is 2. Hence, the sum of the SPF of numerator and denominator is equal to 19. I think you understood the problem and you understood the application of WOLSTENHOLME'S theorem. With this, I want to conclude this session with a note that if there is a value addition to you because of this lecture, kindly share and subscribe to my channel. Maths and Science by IITian. Mathematics is always challenging. Mathematics is always an innovations. Mathematics is full of applications and experimentation. We have experimented with different values, like P is equal to 2026. Because it is not a prime, we didn't proceed further. Then we went for 2026. Any number can be given. In the examination, try to do it with confidence. These are the concepts behind solving this particular equation, and kindly answer my question in your comments. In this SPF of A plus SPF of B, can we treat it as a Diophantine equation? 1 plus 1 by 2 plus 1 by 3 up to 1 by 16 is equal to A by B. It is in the form of function of A and B. Can we treat it as a Diophantine equation if we have to find two variables with one single equation? It's a homework question for you. Please brainstorm and comment in the comments column. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture. Best of luck.